So with these next two chapters, we now begin our study of carbonyls. And when it comes to carbonyls, we kind of break them up into two categories. On one side, we have groups like aldehydes and ketones, which behave in a lot of very similar ways. And we think about that, that's because their structures are relatively similar. So the only difference between an aldehyde and a ketone is that one has a hydrogen attached to the carbonyl, while the other one has a different carbon, while the other one has a second carbon group. And while structurally that is a difference, we give them different names in terms of functional groups, it doesn't have as much impact on their reactivity as we initially might expect it to. We see a lot of very similar behavior. On the other hand, we have esters and amides. And these behave very differently because in both cases, regardless of what this X is a group that can be electron donating by resonance and electron withdrawing by induction. And so the difference in that substituent versus having a carbon group or a hydrogen group makes the reactivity very different. But we're going to start with the first half, which are aldehydes and ketones. And due to the carbonyl, these are both very important and very versatile functional groups. There's a lot that you can do with an aldehyde or a ketone in terms of its reactivity. But as always, we're going to start with some nomenclature. And either one of these groups, if you're comfortable with the nomenclature that we've already learned on other functional groups, then neither one of these two groups should be terribly difficult. And in fact, the aldehyde is one of the easier functional groups. And the reason that we say the aldehyde is one of the easier functional groups is what can often be one of the more difficult steps in nomenclature, figuring out which direction you should number your molecule in. In the case of aldehydes, you actually don't need that. There aren't any options. And what we mean by that is after you found the longest chain, the carbon of the aldehyde is always carbon number 1. And so there's no way to number this other than the way that we have here. So again, you find your parent chain and you number it starting at the carbon of the carbonyl. So this aldehyde is 6 carbons, which we know is hexane. And as we have for every other functional group, to incorporate the new functional group name, we change the ending. And the ending we get is right out of the name aldehyde. So right there, Al. And so hexane becomes hexanal. After we've done that, everything else is as we've learned previously for nomenclature. You name your substituents, you put them in alphabetically, and after that, make sure to remember any of your stereochemical descriptors, whether that's R and S for chiral centers or E and Z for the alkenes. So how do we name this one? Well, again, we're going to start with the longest chain, and we start numbering where the aldehyde is. So we have a 7-carbon chain, makes it heptane, but because of the aldehyde, it becomes heptanal. Now also notice, as we saw for a lot of other functional groups, anytime alkenes, alkynes, alcohols, thiols, any of those other functional groups we've done, we needed a number to indicate where that group was. We don't need the number for the aldehyde. And the reason is, we know that the aldehyde is always at carbon number 1. Now this molecule also has an alkene in it. And so that, as we saw before with alcohols, if we had an alkene, the alkene also gets included in the name. And we do that here. So our heptanal becomes heptenal. The alkene, however, does need a number to indicate where it is. We can see that it starts on the 6th carbon. So this is hep6-enal. And the aldehyde gets priority over that alkene in terms of the numbering. So finally, we can finish off this name by putting in the substituent, which is 4-methyl. And then we're not quite done, because we do have a stereocenter in this molecule. That stereocenter is at carbon 4. There's a hydrogen present that's pointed back. That's our lowest priority. The methyl is 3rd. But what's higher priority? Is it the carbon to the left or to the right? Well, if we go to the left, that puts us on carbon 3, which is a CH2 group bonded to a carbon. Same thing to the right. So now we have to go 1 carbon further. At carbon 6, we have an alkene, and we count an alkene as being bonded to 2 carbons, whereas carbon 2 is just a carbon bonded to 1 carbon. So first priority, second, arrow goes counterclockwise, and we have S,4-methyl hep6-enal. So that's how we do aldehydes. What about ketones? So ketones are a little bit more complicated than aldehydes. And that's because the carbonyl of the ketone shows up in the middle of a chain. But other than a new ending, we follow all of the same rules that we did for alcohols. So if we were naming this compound, we know that we would number it over here, because that's the end closest to the alcohol, and this would be 2-heptanol. Well, the ketone is going to be the same thing. The only difference is the ending. And what's the ending for a ketone? Well, we find it right in the term ONE. And so this is 2-heptanone. Or as we've seen in the past, we can put the number in the middle of the name, giving us heptane 2-one. Now, what if we have both a ketone and an aldehyde in the molecule? Like that. Well, the aldehyde gets priority over the ketone, which gets priority over any alkenes and alkynes. So the alkene gets priority, we number it from, the aldehyde gets priority, we number it from where the aldehyde is. This is a 4-carbon chain, so that is butanal. And then the one weird piece comes at this point. When we have both an aldehyde and a ketone, the ketone ends up getting named as a substituent. So we can see the ketone is on the 3rd carbon. What do we call it as a substituent? It gets referred to as oxo. So this compound is 3-oxobutanal. Alright, at this point you can do some practice and we'll go over that in a little bit.